request, and we talked about some shit we can implement. So, yes, because we are both lecturers. He is a lecturer, currently is a lecturer. I was a lecturer at the Hochschule of Darmstadt, University of Applied Science in Darmstadt. And yeah, the last years we are confronted with modern issues in education. So we are come over with that idea. We will show that we are showing you now. As forward, thank you for the invitation. Thank you for making it possible to come here from Germany and show you our approach. And we are really excited to show you what we have built. Now I hand over to Benedict, and he will introduce you a little picture.
Yeah, good morning from me as well. So, as Andreas said, we are focusing this morning on education, and we thought we would, as they do these days, create a little picture about this thing. And so it's all about chaos education, and that's what they gave us. And it's basically a classroom full of machines, and BSD is sitting there laughing, and the other ones are just having errors and having to deal with all of them. So that's basically what we built. I'm not sure why there's a little Death Star in the upper right corner, but AI is not perfect. So all joking aside, we have a little overview for you. So first we cover the background, what this project was about, and that led into his thesis that he wrote. Then later on, we cover the basics and state of the art, what has already been done, or the prior research, and that will then lead into what we developed together and what we learned from that. Then the system concept, that gets a bit more technical, followed by the structure of the evaluation system. So we made it in a certain way that we make sure that there is a fair evaluation of the whole process. Then we go really deep. We put up our scuba gear and dive into the code a little bit. Then we look at the student feedback that we got while evaluating the system. And that is followed by a live demonstration. That's probably why you're all here. And the rest is then questions from you and anything that was maybe unclear so far. All right. So what's the background? So as I said, I'm teaching a class in the winter term since 2012. Oh, wow, I feel old now. And that is typically basic introduction to Unix and basic concepts of what Unix systems are doing. And what I found is that the students are a little bit less engaged these days and quickly distracted. And it's also that they bring not so much Unix knowledge with them, so I pretty much have to start from scratch. And also, we are trying to create new students for the later workforce. And I found that when we are talking about system administration, then it's very difficult to teach them these concepts by just doing slide presentations. And it's all very theoretical. And if we give an assignment, then it's typically like this. Students nowadays, or since last year, started to have no clue about the assignment, put it in ChatGPT or any other big language model, and then there's a solution. Not that the solution is correct that they get, but it's the less ideal way. So I thought, how can we make this a little bit more engaging? Because later on, they will have to deal with real-world problems and real-world scenarios, and why don't we simulate that in the classroom? Why don't we give students the possibility to work on these systems or a simulation of that and then figure out what the proper strategy is so that when they later graduate and work, then they find, I've seen this kind of problem before. So and that's what we basically built here.
So come to the objectives of our project. The problem is today students don't thinking about their solutions. So I put into ChatGPT and get a solution and give it to the lecturer. So the grant or the marks are not valuable to the performance the students have bring on. The problem is students are not motivated to go to university. They are only doing university stuff, not for learning, so for get money after the university or salaries. So yes, the objective was develop a practical learning concept with hands-on education using principles of chaos engineering because it's a good concept of Netflix. We come later to that. And we were able to restrict the AI abuse in our university fields and increasing the intrinsic motivation of students through the use of gamification because if you have fun on learning, you are not want to cheat to get to that step. So yeah, we use gamification elements. Now, basics and state of the art. Chaos engineering is a concept of Netflix. We have here more employees of Netflix, so they know chaos engineering. There is a concept: a monkey runs through a server room and put out any cable or something else, shutting down servers, and the system should be still working. And if it doesn't, the employees are so good educated to fix the problem fast, so the downtime of Netflix is really low. It's a good concept, and we try to implement that in our project. The result of that is the employees of Netflix are good educated, so sorry for the Netflix advertisement, but it is so. They are really good in solving problem skills and so on, and many companies in Europe use nowadays the chaos engineering concept.
Yeah, and so as good researchers, we looked at, hey, what's already out there that we could maybe use or that we could build upon. And we found two similar systems. So this one is from the Computer Science University of Virginia. And what they do is kind of a bomb lab. If you search for a bomb lab, you get all kinds of weird results. So that's why we provided the URL for you. And so what they have is they give you a binary, and the students have to learn how to debug it properly. And if they just execute it or debug it the wrong way, it explodes. And that explosion causes a high score list to advance. So they get a negative point, basically. And after 10 points, the exercise is over for them. So they have to be really careful and find their way through the binary. And we like this approach because it has this gamification element in there. And the other thing is what we found is that the SAT servers, maybe some of you have tried this out already as well. So that's an AWS environment where there's a real life system and you get an assignment like fix this error or there's something wrong here. And when you think you've fixed that problem, you need to hit a button and say submit solution. And then the result will be told to you and said, yeah, it's correct, or you still haven't solved it yet. What we found there is that you have to do this manually, so it doesn't check automatically whether the solution is already correct. And there's a high score list available, so the fastest sysadmins are basically honored in this high score list. So we liked both approaches a little bit. Both had their pros and cons. And so we found some things could be improved, so we built our own system. And that is basically what our result is here. So what is the system concept and the design that we built? So I had basically the master thesis written out as, hey, students, are you interested in this? And Andreas was kind enough to put his hands on the keyboard and started coding. And that is what we had. So what was the overall idea and the requirements for this project? There are a couple of things that I found would be interesting to have, and we list that on this slide. So first of all, me as a teacher, I want to be able to create new scenarios that I can then give to students and then change it up a little bit from one semester to the next. The other one is that we want to be able to run this in a classroom, and the setup shouldn't be too complicated because you rush to class and you need to set up the lab environment, and if that takes 10 minutes, then the students are already getting a little bit nervous. What we also wanted to have is that we have automated checks of the results, so I don't have to run to each individual student group and ask, oh, are you finished yet? Are you finished yet? The results should be provided to the students automatically by the system. The other thing is the students should be able to work in an isolated environment. Typically, they do that on their own laptops, but they are pretty much all over the place in terms of hardware, in terms of network configuration. So every student group should have their own system that is the same for everyone, but isolated from each other so that they don't attack each other. And they should also be able to work with the root account because many sysadmin jobs involve the root account and they need to fix many things in the root. So that's why we made sure that they have the proper permissions without doing evil things with them. And we also wanted to simulate real sysadmin tasks that they, again, later would probably see again in the real working life. And the solutions could be very all over the place, right? You have typically multiple ways to solve a solution or to solve a problem. And that's what we also thought after such an exercise, after the student have solved it, we would do a group discussion and said, okay, how did you found it? What was the actual problem? And how did you solve it? And in that discussion, we would typically find that there's multiple ways to skin a cat, right? And so that increases the knowledge rather than each student gets the same assignment and they show it to me and then they leave the class and the other students just don't see what other solutions are out there. The other thing is that the high score list should have also certain properties. So we wanted to have the gamification so that there's a little bit of an internal competition going on between the student, like who's the fastest that solves this. And over time, they would get a ranking of what is the fastest group in this. It should automatically update, of course, so I don't have to do this manually. And the student gets feedback, yes, I really solved this now. I can relax until the next exercise hits. Technical-wise, it should be open source. I want to, play with that. I want to change it when needed, and it should not be complicated, not a big stack that has a long, requirements list and stuff. And it should be extendable as any requirements in the teaching changes. So I don't want to dive too deep into the code, so it should be simple enough, like having a config file or something.
So. Now come to our solution. Our solution was important for our solution is a proof of concept, and we are able to use FreeBSD 14.2 with jails, provide excellent process isolation. Now we heard yesterday from the net colleague in the above row, and always able to run commands from outside in the jail. So Benedict can communicate with that jails for the students. Then powerful networking using PF and NUT rules, so we can scalable the student clients so much we want. Currently, I'm limited on 100 student clients, but if some changes in design, we can increase it to 1,000, 10,000. It's no problem. Then we use Bastille to organize and manage the jails. Bastille is Docker-like and work fine on FreeBSD. I tested it well, 2 months ago, and custom shell script for development and management. So it's runs on every system and no one needs every knowledge and additional knowledge to work with that concept. Then cron jobs check jails and update high score list. That's a light drawback, so we come later to that problem with cron. And OpenZFS provides quick jail snapshot and rollback, so we can restore every jail on every hour. We can restore the jail and rollback if the students make mistakes or crash the jail. It was also important because it's in our education field, it comes over 2 times per week that students make any crash in the system, so we need a rollback function. And it's low cost, customizable, stable, and reliable and scalable because jails are fast, jails are cheap, and jails are really performant. So now we come to our concept of the whole education. This border marks the limits of our system. We have in the system student jails, so much as you want. Then we have a controller jail, we have a monitor jail, we have a web server jail. The lecturer can access the controller jail and control with the controller jail. The student jails, you can make SSH requests, he can write text messages, and he can roll back the function, and also you can set up the system. The monitoring jail observes the student jails and look that of any mistakes out of the concept. And the students can also look on the monitoring systems. The web server jail hosts the high score list for the gamification element, where all information were gathered and compact and put together to one point per system. And the students can read the high score list and can jump over the controller system via jump hosting into your jails. So it's able to work from anywhere with the system, with the world. Yeah. The concept is the controller system requests the status of the current exercise they're running, and run a script, and the script gives a reply to the controller system, so the controller system can determine if this exercise was finished. Yes. Now the structure of the evaluation system, it was important to find a good structure for the evaluation system so students are motivated. The students should not be punished if they are not so good in that field because they are learning and they want to improve every day. So let's come over with that idea. We have an evaluation concept based on 3 difficulty degrees. One is easy. That contains simple tasks, we shell change, we are changing the bash or to SSH or something else, and then we are try to run only commands that work in bash, and they won't work, and the students must find out why they don't work, and the processing time is approximately 11 minutes. So that is a quarter of a typical lecture hour in our university. Our lecture hour is 45 minutes. So yeah, then we have the medium degree. That's customized config file, simply one config file or other configs, and it's a half hour of our lecture hour of our university. And of course, surprisingly, the hard one is 1 hour of our lecture. So multiple files, complex context, you can combine the context with other and need some fix many steps and many processes. As example, we need, we are implementing exercise who limits the system by using Apache log files. So we're writing full of the system full, and the students must find out why my system is full, why is it so slow, why it's not stable, and why it's crashing every minute. And then you must fix the Apache log file, the new syslog file was it, with the log rotation, and must fix delete the old full logs. Yes. It was too hard for them, they can't solute it. So then linear point distribution. We want to use a linear point distribution because if you are good, you get many points, and if you are bad, you get not so less points that you are not demotivated. Then we are add a bonus system on that you can make competition between really good and good ones. So yes. If you are, sorry, the expected time is the blue line. So if you are able to find a solution in the time the professor determined that is good for you to find a solution in that time, so you get the half of the points as possible. And if it's not able to do that, you get lesser points. And if you are the double time of this lecturer time, you get 0 points. And if you are really good and you are faster than the half of needed determined time by the professor, you get 50% by 50%, you get 10% extra time. And if you are faster than 3/4, I think, yes, you get 5% extra time. Yes, I do a little mathematical competition and calculate it, so there is a really distance. It's really good if you are one time you get 10% extra time, and the one point you get only the 1,500 points. 1,000 points. You are the lead of the list. But if the it's really hard to explain in English. But if you are not able to bring a third time good performance, then the students, the medium students who get every time the same points are much higher in the list. So it's a good concept and it worked. That's point distribution built on 4 pillars. You have a points, linear distribution points, bonus points motivate to solve problems quickly and efficiently. Then the mathematical combination of time, efficiency, and level of difficulty, and the anchoring effect. Well, I must find out a solution for how much points I give as standard. So 1 point is too less. 100 point is, I don't know, I think, okay, I give 1,000 points. It's valuable. And if you have a hard degree, you have get 3,000 points. And you can easily divide that and was auswerten? Auswerten.
Yeah.
Auswerten. Auf Englisch. Auswerten auf Englisch.
Analyze.
Analyze the points. So the students for the students are really transparent. So you had a fair distribution, rewards efficient work without discouraging and punishing bad students. So then that the point distribution is very ankommt bei den Studenten. Gut ankommen. Mach du. Gut ankommen.
Oh, that it's well received?
Well received, yes, the students. So now Benedict show an example of our high score list.
Yeah, so we did play this with 2 student groups, and these were the group names. I mean, we don't have any custom, it's a prototype system still, but later on they would give their own group names, right? And so that's what the scoring system will look like after playing one round. And we played actually 3 scenarios, an easy, medium, and a hard one. And it's depending on how well you are performing in each of these difficulties. I mean, at the beginning in the easy scenarios, most students got a lot of points. But then later on, when we moved on to the medium difficulties, they were already struggling a little bit longer, and that took longer time, and then they got points reduced, right? And overall, we thought this would be a nice way. So this high score list is basically auto-sorting. So if a group is getting more points, they will jump to the top. And it gives, so we display this during the class, and then they would figure, look, someone has found the solution already, and we actually are now jumping ahead. And the more exercises we play, the more points you get. And it could be that during the first exercise, maybe you didn't do so well, but in the second, you really aced that one, and then you would jump ahead from your other classmates. All right, so let's do a deep dive, as promised.
Now we come to how a student jail creation works. First we create a jail with automatic creation of isolate systems for each group and using Bastille, as I said. Then we apply a template on it, so you can scale the many jails you want. Add controller credentials for setup SSH keys, RSR keys, and so on. And create a snapshot for the rollback to recover the system if there's a failure. Then we add a jail to a logging system, so we can anytime look what our jails are due, what the status of our jails is, and if a failure occurs, so we can find the failure fast. So for the jail creation, pointer you have. The jail creation happens in this line. For Bastille, we create with templates. Then we need a bootstrap version. I think it was a FreeBSD 4.10.2. At that time, then we create a subnet of it for communication and subnetting in PF. Then we apply the template, the name of that jail. In typical labs on our university, we need groups. So the name is group 1 or group 2 in our example. Then we have the root directory of the Bastille template who are mapped onto the template. And of course, here are the right error logs and so on. Then we run the Bastille command for the password and SSH password for the controller on that system. Copy the SSH ID with the RSR keys. They all were auto-generated for each system, and you can read it out of the system if you're not able to access the root system. Then we're creating the snapshot with the snapshot as initial, so you can every time run it back to initial step and give a little output that the group successfully created and configured. Yes. So, kann ich wieder ausmachen? Then the Bastille template for everyone who doesn't know how it looks like. At first lines, we assume the package upgrade is always yes for interactive. Then we are downloading essential packages for most students of our system. That is the template of the controller template, because it's the template where the most action happens. And then I create automatically the host name and user password for the jail, copy the SSH config, enable the SSH services, create a Prometheus YAML, and set up the monitoring stuff. And the last one I made port Weiterleitung? Port direction, yeah. Port redirection.
So this is really useful for me as a teacher so that I can quickly set up the labs. And I also want to see during a lab like which jail is misbehaving, or are students running some crazy services that are just hogging the CPU of the host. So that's why we set up basically a Prometheus and Grafana system. So this is from when we played this with a student group, and we figured it was also a good test whether the performance of our environment would not, crash or anything. So that wasn't the case. And ideally, we would also see if a student did something crazy or started using his root access in the jail for something malicious. And if you would have encountered that there is something wrong in the system, like there's an, I don't know, endless loop or whatever, it would also help us determine like where in our prototype we need to make some more adjustments. And ideally, this is the view we would get all the time when we are playing. And depending on how many jails we create for each group, we would also see that there's like more spikes at the beginning. But then later on, it will level out because then the jails are all running and are set up.
Now, which parts a scenario components contains a scenario? You have a task description, it's a simple text file. Then you have a scenario template, it's a Bastille template with different lines on it. It depends on the scenario. Then you have a solution script. It's a bash script or SH script who does implement the solution the student should find or something else, or all varieties of a student should find. Maybe we could that in future automate with AI. And then you have a difficulty file. It's a proof of concept, so it's a file with one integer in it, 1, 2, or 3. So yes, I don't find a better solution for that. As addition, you can use so many additional files you want: folders, directories, scripts, everything else. So I mapped in the additional files a whole Apache server set up for the hard difficulty degree, and it worked.
And this is easy for me to create a new scenario, because I don't want to delve into a shell script and make changes there. I can say, well, remove the execute bit, or delete this file, or I don't know, copy an additional big file as you did with the Apache log file into the jail, and then they run out of disk space real quick. So that's what you define in here. And you, after you've done this a couple of times, you get really nasty ideas how you can mess with systems. And so, but these are real things that could happen to a system, right? Either by accident or by a service misbehaving. So that's why we found this is easy to create more and new scenarios.
So now we come to a typical scenario sequence. The lecturer selects a scenario. It's a folder. You can put it on a simple GUI in CMD. I will show it later. And then we create a subserver cron job. Then we determine the time before the scenario starts, so the students can log in his jails, but the time they are logged in are not a part of the Bewertung? The marking of their scenario. So then the student solves the scenario. We calculate the scenario points out of many difficult calculations and so on. Then we exit the scenario. Then the lecturer can choose two options: reset the scenario, reset the jail, or running the jail with the same config that the student has implemented. So you can combine the scenarios together. Then the lecturer had optional communication with the jails. He can write any message with emojis. And the lecturer can restore individual systems. You can input the jail ID and snapshot ID, and he can roll back to that stand. So it works fine and was a good solution for us.
Yeah, because I've also thought that the students could get the jail at the beginning of the semester and they would have to manage it throughout the whole semester, and they could install their own favorite tools in there. And if something goes wrong, then we can really reset it this way. All right, time for the live demo. So we thought we would show it because that's the best way of understanding what we're doing here and what the system does and how it behaves. So Andreas will play the role of both instructor and the, there we go.
Little IT issues.
Here we go. So this is the lecturer's view. This is my view. The students never see this part of the system. And that's a jail that the students will get as a group, and that will get nasty errors soon. So you log into there, and I have difficult options, or different options, like initializing the system. We already did that before coming here. Then we can start and select a certain scenario that the students have to then deal with. And then stop a scenario when necessary. We can check how many systems are live. And we also can send a broadcast message to each jail, like taunt them a little bit. Haven't you solved it yet? Or what's going on here? And then, as mentioned, we can also, if a student crashed or cannot log in to the jail anymore, then we can restore that particular jail without affecting the other ones. All right, let's inject some errors into this jail. And so this is what the students get as a scenario description. That's the one we mentioned earlier. This is the student's problem description. And it could be kind of misleading what they can see. But it gives them ideally some idea where the problem might be. And then I look at that and think, yeah, let's try doing a system upgrade. I should probably check if I can do a package upgrade here in this machine. And since they have root access, they are allowed to do that. So let's see if that works. I hope it does. And I get all kinds of crazy network connectivity problems. And then I think, maybe I have network problems. I should check my network connectivity or if I can resolve hosts, right? And so that's, I mean, this is the first idea I would get. Maybe you have other approaches. So each individual student approaches it a different way. And we found that when we tried the scenario, we had two groups, basically. One group was allowed to use ChatGPT and other tools, and the other one wasn't. So we could evaluate how good each group was. OK, so I see I cannot do name resolution for some reason. So then I have to think back to the lecture. Yeah, he talked about something about name resolution. There's a specific file that takes care of this. Maybe I should look into that file and see if there's a proper name server in there, right?
Or the lecturer give the advice. So
and still, during this exercise, I can still send the students jails messages to say, remember your lecture, if you go to those still. And then it will appear on their screen so that they get a little bit of enticing. And while this scenario is running, the high score list is waiting and gets updates if a student group has already solved it. Can you quickly show the high score list, maybe?
Yes, I hope so.
There it is. So currently, there's two groups, and no groups has solved it yet, so they have no points. And now that they have found this little message from the instructor, they're like, yeah, OK, I look back into my slides, maybe, or I recall that there's a thing for name resolutions. And then I find there's an etc resolve conf, I think. And now I take my favorite editor. Of course, you have root access. No network yet. You cannot install stuff. But in a different scenario, you would be able to install your favorite editor. And, oh, let's look at that. That's not a name server that I think is working. So I might as well fix this one and put in a proper one. And now it's time to wait before the system has made another iteration of checking each individual jail, whether the solution is already there. And oh, look at that. I have successfully passed this scenario. Excellent. Let's check the high score list if that is also reflecting this. Oh, and I got this number of points because depending on the time it took me to solve this scenario and also the difficulty of it will then give me this point scale. And group 2 hasn't solved it yet. That's why they're still having no points.
And then the lecturer could restart a scenario selection. So maybe this one.
Yeah, so either I can leave them with their existing jails, and they have to do the next scenario. I can inject another problem into it. Or I say, yeah, OK, some students have solved it, the other ones haven't. Maybe I should give everyone an even grounding again, so that everyone has the same starting scenario, and all the jails are getting reset, and we can now start over with a new scenario.
Should I reset, or?
Yeah, why not?
But then you are kicked out of the system because it's the current
because
design.
your system doesn't exist anymore. We delete the jail and create a new one for you.
But you can play this any time you want. So many you want, and yes, it worked. And for someone interested in it, the whole technique behind that magic is only through writing into files and combine the files together, because it's a proof concept.
Yeah, it's a prototype system, but luckily we got to a point where we could evaluate it with two students. Yeah, you got a question?
Yeah, so when you just reset their machine, do they just push up and log in again? Is it the same IP address, or they gotta?
Yes.
Yeah, so the question was whether when we restart or restore such a system, whether they get the same IP address. Yeah, that's been preserved, so they don't have to get a new IP address or DNS name, so they can keep that one throughout the whole semester. And while the scenario is playing, we're also logging a couple of steps, what the system was doing in the background, because there could be some implementation things that are not working, but so far that went well. And this is the actual
high score
points that this group got.
Yes.
And the high score list is just displaying what are in these individual files.
And here are other important files, what are the time exclude before the scenario, time records during the scenario, and the result file where one simple line is in it, failed and successfully. Maybe I can show it.
There we go.
No, there's nothing. We have stopped the scenario. So after you stop the scenario, you would
the result would then
everything
also be
of the old
obliterated.
scenarios. Yes.
And again, for me as a teacher, this is a very helpful system because I don't have to deal with cleaning up jails afterwards and collecting the points still. And the students could really see the results right away. They get immediate feedback and find that they have solved the scenario. And the gamification is then, oh, I was faster than my other student peers. All right. So as I said, we evaluated this with 2 student groups. One was allowed to use ChatGPT and other AI tools, and the other one was forbidden. And we evaluated the individual results that they achieved. So what we found is that the teaching concept, so we gave them a little questionnaire at the end and asked, hey, how did you like this kind of exercise? Is this better than the standard one we give you? And they said it was very motivating and they were challenged in a different way. And some people remarked that this gave them unnecessary pressure, but that was our intention, so that there's also, you need to fix it quickly because in the real world, the production is down and you need to fix it quickly or the company loses money. It also reflected that they strengthened the practical relevance because this is really a scenario, or could be one that is happening in the company or in the later life, wherever they end up. And it promoted independent thinking, that they sometimes aren't quicker when they use AI because the AI could be all over the place with solutions, but you still also have to prompt correctly and give the information to the system. And some students just look up in these slides or remember that we talked about this last week in class and figured, this is what he's getting at. And many wished for more of that. So that gives me a hope that the more scenarios we create, the more likely it is that students will get to know into the content and want to work with the system more. Functionality-wise, we were lucky that it didn't crash during the exercise because that would be very embarrassing. It was stable and reliable, the scenarios loaded correctly, the SSH access worked correctly, and we had no slowdowns for one group or the other, so everyone had the same environment and could work with the system. And the transparency of the evaluation, they also liked that they could see how many points they got, and that there was really a good way of thinking and finding, yes, we are actually better than this other group.
So then the user-friendliness, it was important for me that students can easily use that tool. And of course, infrastructure as code concept that you can run it everywhere. Our approach in university runs on OpenStack. Before that, this runs on natively VM, I think.
Yeah.
Natively VM. But unfortunately, we can access our university network because the limitation in that VLAN here.
There's a couple of ports
so
blocked. That's why we use this.
Yesterday, we're setting up a new short lab, yes, on VirtualBox. So yes, then the suggestion for a proven visual web interface students. Students wish that they could see in the high score list how many points they get for which task. So they can read it and look it into the slides and can say, okay, I need in that topic more improvement and more to read over the stuff. Yes. Then the scenarios we are evaluated with difficulty keyword analyze. So shell change was good. DNS manipulation, this was that one where I showed in the exercise here, was also good, but log rotation with the Apache file was too hard. I think one group with ChatGPT, and after 2 hours can find a solution for that. So yes, but overall rate it was good and exciting. So this was important for us that the system worked, and we showed it other colleagues of us, and they are really excited to use it in their lecture for system, IT security, network administration, and so on. And yeah, then the outlook for the future development is expand the variety of scenarios. So we have many ideas of different scenarios. Maybe there are kernel errors or something else for really difficult scenarios. The problem currently is the 16-second limitation of cron jobs. You can run a cron job only in 16-second intervals, yes. And that's the problem. So I think real WebSockets or Notify concepts were really good for that thing. And high score list, more transparency, what I said, because the students would look into his high score list and would see how many points you get for the tasks. And transferability, how we can use it for network technology or other stuff. That's the next steps, and maybe you can use it in hackathons and FreeBSD conferences if the system runs well and we can exit it from here, because my laptop is not so fast than the server. Yeah. Any questions?
There they go, one by one. Where do we start at the right at the top?
So from my side, I would have the question, did you feel the need and or implement any infrastructure, any resource limitations on the jails, or where the students behaved enough or that they didn't by accident or on purpose overstress the system?
So the question was basically whether the students did overstress the system or had a situation created that slowed down the other jails. We didn't have that yet, but we should probably try this so that one jail is just attacking the others if they find their IP addresses. So the students could really be in the situation, this scenario is boring, I just use my newfound powers to do malicious things. It's a two-edged sword, right? You want to give them the permissions to do all these administrative tasks, but on the other way, this could also be abused to not solve the scenario that we were giving them. Maybe we need to think about resource isolation a bit more to say, oh, this jail has only maybe 1 gigabyte of memory and can only use 1 CPU and such. And that would also allow us to add more jails. Our typical class size is 16 students. We typically form groups of 2, so we have 8 jails. But if we would really play this at like an event like this and say, okay, this is a specific time slot where we play this, and a lot more of you would try this out, then I guess we will have more load in the system. But it's actually a good use case, right? And especially in here with a lot of sysadmins in the room as well, we would get some really different results over time. So maybe we'll do something at a future BSD event.
But we are very happy if students are so good that they come to that point that they are annoying us on that system. So, but in a real thing, the students at HALT today have problems to use CD to change directories. It's no joke.
Yeah.
So
at one point we have learners. They still want to learn and don't get frustrated by not solving the scenario. Whereas here we have more advanced or seasoned sysadmins that pretty much can solve these real quick. But the scenarios can get really difficult. We have some ideas to really make things difficult for you. So yeah, this is a future idea we will probably have. I repeat the question. Oh, yeah, you know how it goes, yeah.
So the big problem that I find is that undergraduates in the course computer science don't really have any Unix education at all classes. The first class that a lot of students will have exposure to Unix is also the first one they'll be using the command line and also programming in the C programming language. It's all just kind of one, and the instructors don't really provide an opportunity for students to were the students in this test, were they general computer science or software engineering students? Were they like more sysadmin-focused program? Did you notice any difference among students in a particular program, how well they did with this?
Yeah, so the question was what kind of students we had in our evaluation and what the difficulties were, basically. So this is my elective course, Unix for Developers. So it's only students that really want to learn about Unix, not that they have to. And these are typical students that are in their 4th semester, so they have 2 years of programming already and a little bit more of, so they had operating systems and distributed systems typically. What you said also reminded me that what we have also seen in our CS department, so these are computer science students, that in the operating systems class, they learn concepts like schedulers and clocks and all these internals. But what students want these days is, how do I administer a system? How do I set up a web server? How do I create a little system of my own, right? And that's what student asked me, hey, can we do this in your class? That's why I added the sysadmin components into mine. So this is really more interesting to the students. Right, there was something over here.
Yeah, I really wish I did have this in my classes. So a couple of things. So I was wondering how you guys would handle, for example, partial marks. So like for the hard difficulty, it might be a multi-step process, right? So would you like send a webhook or that sort of thing to signal the snapshot to be searched again to get partial marks through it?
So the question was, how do we deal with like partial writes and stuff, and how the WebSocket could potentially solve that? That's what we have to figure out, because, for example, if a lot of students finished the example or the exercise at the same time, there may be a race condition with the writing of the high score list score. And typically it doesn't happen, but we could definitely simulate that by piping in the solutions into multiple jails and then see what the high score list does out of that.
We are trying to prevent that during batch handling. So we use 5 batches. If you use no batches, they are crashed in the former solutions. So yes, we use 5 batches, and it's really fast and it works well. So yes.
But yeah, the more parallel systems or parallel things you're doing, the more difficult it will be to do the proper scoring, which would also be a bad motivation for the students if they, oh, I solved it and these students next to me were also as quick. Why do I not get the points? But as a prototype, I was really surprised how quickly we got to a working solution and could iterate over that. And of course, it's just a prototype, but I see a lot of potential in this to either add more scenarios and also more functionality to the system itself to be more robust and provide more functionality for playing this in like a setting like this with multiple people accessing. And of course, you people could also think of much more malicious things to do for the system, I guess. And so this is also showing how robust our system will be then.
Yes.
So that I'm looking forward to actually to have some kind of test like this. Yes, roll.
So rather than cron being the thing that runs the script, couldn't the controller just Ansible to everybody, and just anytime it wants to, it can just be like run the script, check the score?
Yeah, the question was, instead of a cron job checking these jails, it could also be like an Ansible script that goes through each jail and asks, hey, have you solved it? Have you solved it? We thought about that, so Ansible could be run in pull mode instead of push mode, because in push mode you have to run the command yourself or schedule it in some other way. And that would probably be something we could evaluate. So maybe I'll let another student evaluate this, or if you have some time left, yes. You could do that. It's possible. So we thought about a certain number of solutions before we got to this point. Like what we did in the first iteration, you had a folder mounted into the jail where the result is then stored, but then students could actually find that folder and manipulate it and increase their scores. And so we did away with that solution and found that you can always, from the outside, access the internals of the jail without the jail inmates, the students, don't see what you are doing in the outside. So that's, I think, a much better solution, hiding the activities of the instructor.
I thought about Ansible, but I need to move forward because I have limitation of my master thesis, so I need to fix the next step.
Yeah.
Yeah.
So we had 6 months to do that, and after maybe the first month, we had a rough prototype with the jail
Yes.
set up, and then
Really
we
rough.
iterated through that. That doesn't work, Lone. I don't like it this way. Do it in a different way. And so that's why we have a system like this. And we were also lucky enough that we found a student group to evaluate this with, because otherwise it's a system, it works for us in our limited test environment, but if you really play it with a group of people, then you know all the things that could break. And there were a couple of things that did break during the beginning that you quickly fixed, luckily. But now it's in a state that you can really play with that and create your own scenarios. You basically, maybe you can show that, how a scenario folder looks like the difficulty and what you can...
Yes.
You basically write a Bastille script, and that's where you say, oh, please delete this file, or remove the execute bit, or mess with the system in some other way. So you don't have to learn a complicated programming language just to create a scenario. Yeah?
Something else, sorry, there's others, but
No.
something else that this reminded me of was, I don't know if you've heard of Reuschling. It's kind of a curriculum for learning the Rust programming language, where you have a window and then it has a watch for if a program is compiled, basically. And so I was wondering if you thought about how a system like this could be used not only for evaluation but also for instruction. If you could, you could say like, hey, this is a problem, and populate the jail with man pages that students could learn about the system while they're there as well. Something that came to mind as well.
Oh, sure, yeah. So the question was, or have we thought about using the system for instructions, like removing the man pages there and making it a bit more difficult so that they have to refer back to my material or the class material? Sure, it could also be used in like sysadmin training in a company, for example. Like we want to replay a scenario that happened last week, an outage, for example, and one person who was on call solved it. And we now want to share that knowledge in the team so that if someone else is on call with the same problem, that they know what to do, right? And that they can, in an environment where there's no danger to affect the production systems, you can really replay this kind of error and find that there is a solution to that, and discuss then with your colleagues how to best solve that and share the knowledge this way. So I always, when I play this scenario, and I plan to do this in the winter term again, that there is a phase where we play the scenario and then we stop everything and then come together as a group discussion and say, okay, what was the error? Is everyone agreeing that we had the same error scene? What is the solution that individual teams provided? Like we look at the high score list and go through the groups and say, well, how did you solve it? Oh, we solved it in a whole different way. And that way, with that group discussion, everyone understands that there's multiple ways to solve a problem, so there's much more knowledge sharing happening.
In simple words, we both combine our ideas of our
The
experiences over times, over years of education, and want a system who prevent every failure, every problem with students, keep the students motivated, and so on. Yes.
And the more scenarios we have, the
Yes.
more I can select from, right? And I can
I
think
can
of
mix
some
them.
really nasty things to do to systems, right?
Are you looking for scenario input?
I guess we can have a talk later and
Yes.
you give us a couple of ideas.
Like, is there an online repo we could check it out?
So we plan to eventually productize this enough. There's still some
Yes.
rough edges in the system, but we actually plan to release this as open source to let other people play with that and extend it in their own ways. Because if I can use it in my line of work in the university, then why not share this to other universities that had, like you mentioned, you had or you would have liked to play this as well in your classes. And if instructors see this, that this is available and it's fairly easy to start with, why not? I mean, the more scenarios that are out there, the more the other instructors can use.
Yes.
How many scenarios do you have right now?
6.
One for each difficulty, because it was as a thesis work for him. So we have one easy, medium, and hard. Well, can you show them maybe?
I think so.
So the first one is this scenario is where the shell accidentally changes. And it's really weird how students freak out if the shell that they are used to is not working. The other scenario is the one we saw with the DNS change. So we just removed the DNS server and let them figure out how to solve that. And the hard scenario is we have a big Apache log file that just fills up the jail file system. And they get all kinds of crazy error messages and their slowdowns. And so they not only have to find the file that is responsible for that, but also implement the log rotation so that this doesn't happen again. Because, hey, I can inject an error a week later, right? And then really see if the students have learned from their mistakes.
There are the scenarios. DNS manipulation, log rotation, big file, logging down, shell change, an undeletable file.
Yeah, maybe we look at that shell change.
Shell change, okay.
Yeah. So it's not very difficult to define such a scenario. And as an instructor, you would have to play this scenario through for yourself to see that everything's working. But it doesn't take me an hour to create such a scenario, right? I think of something evil or something that I found in my line of work that happened, and then I think, this is actually a good scenario. So what are you doing here? You're copying the...
PKG. Ich-Eclipse.
Oh. Yeah.
The idea was I need a way to use bash commands without give students a hint that I use bash. So I compiled C++ file who you are calling a system call to using bash, and if you don't install bash, the system call won't work. So I compile it, and the students can and I copy that to the system and delete the original source file, so the students can't find out which command they need. And they need to show on the error message you get bash not installed. So it's really easy, but students sometimes don't find the solution. Yes. So in the first line, I install the C++ compiler. Then I compile the bin, the C++ files. Then remove the C++ file and write the funny message out if the students don't find the solution. Yes. That's all, and in the checking file, sorry, keine Ahnung.
What I also liked, what Andreas did that I haven't thought about, to create these kind of wall messages to students so that we can taunt them during the scenario a little bit.
In the checking file, I only show if the C++ file wrote, that was the bash command, wrote a file in the temp folder with success. So yes, if you know that, you can cheat, but the students doesn't know that, so they can cheat. Yes, and then I write my ich hab's auf Deutsch geschrieben. So my solution timestamp and my keyword success or failed behind it. That's all, because proof of concept. If there are some more questions, you can contact us.
Yeah, we're around the whole day.
Yes.
And once you get the idea of what the system does, it really starts, creating, I could do this, or I could think of such a scenario. And this is exactly what we wanted, right? We want to make it easy to create such a learning environment and then create the scenarios over time. And the more we have, the more choice there is. All right, then thank you.
Thank you.